So you can see here that I can move my axis 3. I have some circuit dynamics in the robot. I have some joint limits already set. And yeah, that's where you can start setting up with new robot. Hi everyone, Dr. Denis from robotics here. If you ever wanted to use ROS like a pro, then this is a video for you. In the ROS for Pro series, we show you which tools we use at Robotized and how we profit from them, and hopefully you get one or another idea so you can also become better robotics developer. Today's topic is our RTW tool, show you the usefulness. In the previous videos we have shown you how you can install it, how you can pull the packages, how you can check out workspaces. But today we want to show you which other scripts you can get use for, because based on that in the continuous videos I will show you some tricks that we are using in our daily work to be very, very fast in robotics development. So let's start. So here, as always, I have just updated my RTW. Make sure that you also always keep it up to date. We are doing quite some releases from quite often time. And then basically we start from our home folder. And for this, we want to create a new RTW workspace. This means basically completely fresh one. For this, I go to tutorials and I go creating new workspace, because although I'm author of it, I don't remember all the commands all the time. So the good documentation is always important thing. So now we open our bash console, and now we can just create, let's just create this workspace without Docker. We want to create local workspace. And we will call this workspace my robot workspace, because later we will create a robot. Let's just do this on Jazzy. Let's see how this will work. Okay, it will not work because obviously we don't have Jazzy installed on this computer. So we go with rolling. And then I get that workspace already exists. Really? Okay, because I just created it, but this is actually then a nice thing. Then you can easily delete it. RTV workspace delete from new version, my robot workspace. I have no idea what there is, so I will just delete it. It will also ask you what you want to delete. I say in this case all. Usually shows you all the subfolders. If you are using Docker, it also shows you the Docker. So this is already one of the very useful feature. So now let's create it again based on rolling. Now we have it, RTV vs my robot workspace. Now I can check it out. This is how I check it out. And now I, of course, need to go into my source folder. What do we want to do? We want to create a robot description. So let's just do it. So it tells us we have to go into package of the robot description. So probably first we should create a new package. So let's take this command that we have here. And then I paste it here. It's called create new package. What will be my package? My cool robot description. Let's name it, and let's have here some cool description, description. Let's call it like this. Package with meshes and kinematic description of my cool robot. Okay. So we create it, ask us, are we sure that we want to do this in this source folder? We say yes. We want to create Thunder package. If you don't know the rest, just leave it. I don't have local git email found, so I will just add it. Now we have it. It will be added as maintainer info. And let's say we just do currently Apache license, and we always do and CMake. So nowadays we don't do and Python packages anymore or pure CMake packages anymore. They theoretically work, but they are much more cluttered, I find. So our rule is internally that we go only with and CMake packages. Then basically you get everything repeated, what it will be done, which robot package is created, where, which description, license, and so on. And if you are happy with that, then you press enter. And now you should also get the package created. So it created all the files. And ask us, do we want to set up repository? Let's in this case just say no, because repository is not important. This is when you want to hook it up to GitHub or GitLab or similar thing. Okay, now we have got our package. Now we should be already able to build the package. So you see here in the manual, you should go cd, build, blah, blah, blah. Basically, we have our alias that is called cb command, okay? It basically does build. It's called a function build in RTW framework. And this basically enables you just to build the whole workspace. Why it's a function? Because it also reacts. So if I say I want to build only one package, doesn't make sense now because I have only one package. Then I can literally here choose which package should be built. So I would just add my cool robot package, and this way I don't need to remember all of this package select lines. And you see that the package is not known. Why is not known? Because I didn't source my workspace. I actually always use even then again RTW. Of course, you can always do source install set a bash file if you like, but this is much easier for me. And I see that, because I'm wrong, it's not my cool robot package, it's my cool robot description. So basically you see it sends this to package select and now just compiles this package. Otherwise you have you have basically the same output because we have only one package. But we can even create already package. So let's create also another package for bringup files already. Wait, this was create new package. Let's say here my cool robot bringup, and here we have bringup. So basically launch files for my cool robot. Okay. Again, ask us where, how. I basically do the same thing as I did before, and then I set it up again, no, and then I do CB. And now if we will check, now we have built two packages. Now I want to source my workspace again. Wait, VS my robot workspace. And then now I can do CB only on one package. So you see now we can build only one package. If we run CB, we will have both packages added. So this is basically aliases and functions behind, saves you writing a lot of flags. So CB is one of the thing. So, but also I can say CB up. This is basically up to something. Up to, of course, need a package. So I do up to. Now it will be only package because we don't have a tree. But later when we will have a tree, then this will be also very useful to compile only that tree of a package. So for example, bring a package, it compiles also its all dependencies. but not other packages. For example, if you have move it, it will not be compiled again, or similar things. That's something very useful what we have. All these aliases you can find. Now it would be great if I can tell you it's here in use cases. In use cases, you can find all of these aliases. They are described. There are different things, how we use them. Do you want debug, release, building, whatever. Also, you execute testing, execute building and testing, and so on. So basically, CA, CB, CB up are the commands I'm using the most. The other are just added because I needed them at some point. Also, what I'm often using, CRM. I can either remove everything from the workspace that is installed, or I can just remove certain package to do fresh recompilation, because sometimes CMake doesn't detect some changes, and this is needed. So this is also one of my favorites, if you ask me. Saves a lot of time. Also, one thing we will cover in the future, Xeno, we have just added it basically 2 weeks ago. Extremely interesting stuff, basically that you can run Xeno without much thinking. That's what we are doing all the time. Yeah, they are very, very useful things. Basically, as soon as we need to write one command 2 times, we integrate it into RTW, one can say. So let's see. Now we have this, and now we want to actually do our description. I was in quick start. Let's create description package. Or yeah, we can do first description. So we have to go to create robot description. You must have package is built. And CMake, it's written because we are supporting only and CMake. And now I will just enter this package. So you can then do our ROSD command. Basically, ROSD command brings you always to workspace. Okay, so you can see here I'm in the workspace. You have ROSDS. This brings you into source folder. But if you do ROSD and then my cool robot description, you will be you will be in the source folder. You see of the source folder of the package. So this is also that you don't need to remember where you are. There are basically magic done there with the paths in the background to do so. So let's now just do setup robot description, and we will call it my cool build robot. I don't know which robot will come out, but let's call it field robot. Regarding launch files, I have a rule. We use nowadays only XML launch files, so we do only XML. It tells us now it will set up description. Basically, these are templates for you to write your specific description, but first you set a bunch of files, and now everything is done, everything is compiled. And you can test configuration executing this command. Let's see if this is working. Should be. It seems so. So ours is starting. And this is our not wheeled robot. It looks almost wheeled, but it's actually a bunch of cylinders because here we have the robotic arm. We have also, I think, in our templates, a wheeled robot example, and then we adjust this always to something. But this is basically where you start. You know, you set up your view robot or view robot launch file, and there where you start setting up your kinematics. That's basically where we always start to do something, and we have just added those frames here to look kind of half sensible. But it's the idea to have the full structure of all the files. We will not go to investigate files right now. Everything is described there, but I just wanted to show you. We'll do this in the follow-up thing. And now also let's do for the robot bringup. So I should also have auto completion here. No. I have to do not DS, but ROS-D, my cool robot bringup. You see, this amazing. Tab is your best friend. Very good. So bringup, setup, robot bringup. Here we will call it also my cool wheeled robot again, and then a description package is my cool robot description. I will just copy it from here. Yeah, you should have bringup package. We have it. That's it. Let's see what happens. Okay, now again we just said we want to have the XML launch files. I would recommend you always use XML launch files. There is no reason. I know one plausible reason to using Python launch files. Use XML. They can less, much more readable, pressure you to do proper code. Another discussion we will cover in another video at some point. So let's see now what happens here. Okay, something is here not okay with the parsers. Just one correction to our last video. We were having issues starting our created launch files and robot bringup files with ROS2 control of our robot. So now I figure out the issue. It was actually a typo. So let's check it out. So here you can see that I put wheeled without E between L and D, and that's why nothing worked. It was easy to fix. So now I have already compiled and created new package. So now we can just start it. And as you will see, and as I hope you can see in the background, nothing will happen because RVS is false. So we will put it here to true. And then we can, for example, also start RVS, or RVS were started without robot, of course. And let's say we want to also now move the joint trajectory controller, just to show you that. Then we need again my robot workspace. It's called our workspace. I can start RQT. No, RQT. And then in RQT, I should have this plugin installed, AR Robot Tools, Joint Trajectory Controller. So I have already so you can see the Joint Trajectory Controller exists. And I don't know, let's move axis 3 because we see it very well. So you can see here that I can move my axis 3. I have some circuit dynamics in the robot. I have some joint limits already set. And yeah, so I would say thank you. We covered a lot today. Remember, using such a tools, it's very, very useful because it reduces your time. You probably have your own tool. This is our invitation. Let's make something together. That's why RTW exists. Looking forward to see you there. Looking forward to your comments, what you would like to have in RTW more. And we stay in touch. Bye. Until next time.